Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Bromine addition to alkenes proceeds via anti-addition through a bromonium ion intermediate, and the stereochemical outcome depends on the geometry of the starting alkene. Moving on to the next step. In CIS-2-butene, both methyl groups are on the same side of the double bond. The carbons involved are C2 and C3, each bearing one methyl and one hydrogen. Moving on to the next step. Br2 attacks the pi bond from one face, forming a cyclic bromonium ion. The two faces of CIS-2-butene are enantiotopic, so attack occurs with equal probability from either face. And for the final step, the bromide ion attacks anti to the bromonium ion. Because the double bond is CIS, anti-addition places the two bromine atoms on opposite faces relative to the carbon skeleton. Anti-addition to CIS-2-butene gives 2R, 3S, 2,3-dibromobutane and 2S, 3R, 2,3-dibromobutane in equal amounts. These two structures are non-superimposable mirror images, enantiomers, so the product is a racemic mixture. A. Achiral, incorrect, the individual enantiomers are chiral. C. Meso, incorrect, meso would result from anti-addition to trans-2-butene, not CIS-2-butene. D. Optically active, incorrect, because equal amounts of both enantiomers are formed, the mixture is racemic and shows no net optical rotation. Therefore, the correct answer is B. Therefore, the correct answer is option B.